This question says, in the given gear train, which shaft will have the slowest rotation? Is it shaft A, where we have this large orange gear A? Is it shaft B, where we have two gears, gear B1, the smaller gear, and gear B2, the larger of the two on shaft B? Or is it shaft C, which has only one small gear, which is identical to gear B1? So just to make clear how this gear train is set up, we have gear A, so the gear on shaft A is meshed with gear B1, and as it rotates gear B1, shaft B will rotate, and therefore also rotate gear B2. If gear B2 is rotating, well then it will rotate gear C here on shaft C, and this is the full setup of the gear train. So gear trains are used to increase the gear ratio without taking up much space. So if you compare what it would take to create the same gear ratio with directly meshed gears, it would require a lot more volume. And you can see there's some spatial overlap here that helps reduce space. But if we're concerned with which shaft will have the slowest rotation, well, we need to consider the number of teeth and the way these gears are connected. So first we have gear C and gear B2. We can consider these first. Now, the number of teeth of C is fewer than the number of teeth of B2. And the gear with the lesser number of teeth will have the higher rotational velocity. So therefore, the rotational speed of C will be greater than the rotational speed of gear B2. So we know C is faster than B, but let's continue through the gear train. So C rotates B2, and B2 rotates shaft B, and therefore also gear B1. Now, gear B1 will rotate gear A, and therefore shaft A. But again, the number of teeth of gear B1 is less than the number of teeth of gear A, and therefore the rotational speed of gear B1 will be greater than the rotational speed of gear A. So that means as we go from C to A, the rotational speed of these gears will decrease because we have a smaller gear driving a larger gear, which then again sees a smaller gear driving a larger gear. So therefore, the correct answer is A.